Welcome back to another Unity 5 tutorial. In this session we're gonna work further on our area tool. What we are trying to finish is creating the 3D shape of it. So last session, the last thing I was mentioning was that even though if I hit play now, we can see from the bottom we are actually creating already a mesh. And I was saying that the mesh collider though doesn't work yet. So reason was if that would work already, we would maybe not even need necessarily a 3D object. But yeah, I just want to demonstrate why it's not working, or that it's not working. So let's open up the area script, and right on top I'm gonna add another required component, which is the mesh collider. And in our create script function, we just add right after the mesh filter the mesh collider. So let's say mesh collider MC. We get a reference to it via get component. And there are a few things we need to set. First is the shared mesh. There is no mesh attribute. There's only the shared mesh. So this is what you can see in the inspector, and we set this with our newly created mesh. Then we need to set that it's a convex shape. So I believe starting Unity 5, it's not allowed to have triggers on non-convex shapes. So we need to set this on true, otherwise we'll receive an error. And we need to set is trigger to true, because we want it to work as a trigger. So in order to see something, we just add a function on top, void on trigger, enter. This one takes a collider as parameter, call it other, and just a log statement inside here. Other name. Entered the area. Okay, something like that, and I'm just gonna prepare that for later already. Have an on trigger exit. Just change the I just want to change this log message so we can distinguish between entering and leaving. So now we can move back to Unity, have a look at our object. So since we've added this one by hand before, it's not, the mesh is not assigned, those bools were not ticked. So let me see. Actually, the mesh is assigned as we press play. Or actually, all of those values are assigned, so we must not worry about that. Okay, and now you can see the mesh is assigned. We have a convex shape. We have the trigger set, and now you see this interesting looking mesh collider around our shape, and that's the problem I was trying to address at the end of last session. So Unity does not see this shape as a 3D shape right now. It's only a 2D shape, and a mesh collider is a 3D element, so it is not working properly. Now at the end I was also saying that we need a top and the sides, which is not fully true. We actually only need another top face, and then Unity will already see, okay, this shape has exists in 3D space. So we're gonna, so it will then resize the mesh collider automatically. But we'll leave that for later. This is actually the next step, what we wanna do. Hit play again. From the bottom, we can see our bottom face, and now we wanna add a top face. So the first thing we need to add are vertices, and I'm just going to use a lot of copy and paste here. Let's call this top, rename this to top. So again, I'm just always clicking, right clicking the variable, refactor, rename, and I just want to keep it clean. I want to keep it readable most of all. So, and now we need to think, how do we get our vectors? So I brought this little illustration, like the video if you like the dotted line in the back. So we have here our vertices, the way I want to set them up, or like the bottom part is already set up. We have 0, 1, 2, it's going clockwise. And all we need now in order to get the position for our top vertices is to take our bottom face vertices and add a height value on the y-axis. I want to go straight up. I don't want to move around in any direction, just straight up. So that should be easy. For that we can set a public value. Let's call this height, since it's the height of our area. It will be a float, and I set a standard value of 5. Yeah, that should be fine. And so all we need to do is actually get a reference to the position of the bottom vertex, each bottom vertex. So this would be a vector 3 position. So now we got each position, and in we're gonna add a new vector based on that. So it will be position.x, position.y, position.z, and on top, or additionally to our y value, we'll add our height. Add the parentheses properly, and this is it. That's all we need to get the right positions for our top vectors. Just need to add them to our list. There we go. So now we wouldn't see much yet because we're still missing the tries. So I will just go ahead and copy and paste that, add this part right away. Sorry, I'm jumping around a bit. But this is right now not really rocket science, so I don't want to spend too much time on it. So refactor this one to top. Okay. Before we move on, let's just have a quick look again on this beautiful image. And now with the tries, we need to remember how that whole thing works. Let me just draw a line. If we imagine we have a line here, so this is our bottom face. All we did was to assign, do I still have that? Oh. Assign the indices of our vertices into an array or a list. What is it? Oh yeah, it's an array. So like this was our example we've had before with 6 vertices. Anyways, so all we do is we're placing triplets of indices in this array, saying the first triangle would be 0, 1, 2, clockwise in this case. So now if we want to continue, we just need to think what those numbers mean. So they just represent, and each number represents an index in our vertex array. So if we want to start creating tries up here, we basically need to count all those vertices and use them as an offset. So let's do that. We create an offset, and this is nothing else but the length of our points array. So we have 3 points, waypoints. So this means here we need to start with the 4th waypoint, with the 4th vertex. And now that we got this, there's actually not much more to add. We just need to start. 0 would be then our offset value. And we need to add that on these both cases. So now we basically go through the same procedure as before. We just added an offset, and so now we're doing it up here. So I need to save that script, move back to Unity, and now we already will see a result. 2 results actually. So the first thing is we see our top face is being rendered, which is nice. And you can see the box collider figured out, oh, this is actually a 3D shape, so I am able to render it or to adjust to it. And now if we use, let's say if we add a cube, now that will get a bit tricky to get it on the right position. Let's have a look from different angles. So that should be all right. Okay, that doesn't work. I forgot something, sorry. Let's add the cube not in play mode. The cube needs to have a rigid body, since the trigger, without gravity please, the trigger only responds if the object entering the trigger zone has a rigid body, or there are also other components that could trigger the trigger, but rigid body works for now. And now we need to make sure we're not right in it from the beginning. I think that should work. Yeah, we're outside our triggers. Now I hit play. We're creating this trigger shape, and you can see as I move that onto the cube, we have our message, hello cube, you entered the area. And now if I leave again by cube. So it is already working, but you know, this being a tool, that just doesn't really look nice. It's nothing you want to work with, just a shape that is kind of there and kind of not. So let's just fix that and add some sides to it. 2 errors we still need to fix. One is our top face is only being rendered from the bottom, so we need to flip it around. We can do that in turning around instead of our triangles being created clockwise. We're gonna create them counterclockwise, and that will do enough to flip them around. And another thing, if you can see that there's an offset here, and that one actually comes through our offset, or the position of our game object. So if I just move it around on all the axes, you can see now this is completely loose from our game object or our area object. So let's fix that first. And the error is in our vertices function. So instead of using the position, we need to use the local position. And since we used copy and paste, we actually need to adjust that here as well. Those are the downsides of copy and paste. And the other issue was that our our top face is the wrong way around, and all we need to do here is really just, oh, excuse me, take the middle coordinate or index and move it to the end. So instead of going from 0 to 1 to 2, we're now moving from 0 to 2 to 1. Sweet. Save that and hit play. So first you can see we don't have the offset anymore. It's all there where it's supposed to be. And now we can look from the top onto our object and we can see the face. And of course we cannot see the bottom like this. Let's just add some sides to be able to see it as a 3D shape. So we start again, same procedure as before. We need to start with our vertices first. Let's just create an empty function here called getSideVertices. And now we just need to have another look in here. So for our sides, we need new vertices, but actually we got them all already. And we could reuse them. We could say, well, let's just take the same, but I think it's actually more helpful to double them. As I said before in another session, we did not add so far any UV coordinates, so we cannot place any texture on top. But if that ever would be something we want to do with our tool, it would be necessary that all those vertices are doubled for the sake of the normals, for example. I think there are other reasons, but that's the one I know. So if we have a face up here, we want our normals, of course, to point up. So each of those vertices would have a normal pointing up. If we now want to reuse the same vertex on our side face, where the our normal, like here, they would move up. Oh, beautiful. But if we would want to use this vertex on this face, then we also want it to show in this direction, same as the face. So in order to achieve that, we just need to double this vertex. That means we actually, for creating or adding the right vertices in the right order to our vertex area, we just need to iterate through each face. So first we start with this one, then we start with this one, and then with the back one, or other way around. And then we just need to add each vertex. So number 0, number 3, number 5, number 2. Okay, so how are we gonna do this? We're gonna get a reference to our top and our bottom vertices first. So we need a list of vector 3's bottom and a list vector 3 top. So that means if we now copy and paste this part, call this sides, let's call it sides vertices, it's multiple of them. First we pass in the bottom and then the top. Okay, and here we just need to add another list called the sides, and at the end of our function, we want to return sides. Yeah, we can just return it as that. It's a list already. So first we need to know how many faces we have. Let's call this amount faces. And this would be, or one way to do this would be bottom count or points length. Yeah, let's just use points length because we've used that before as well. So I think that's just, oh wait, let me get rid of all my drawing here. So that just makes total sense, right? We have 3 points, so that means we have 3 faces as well. Always in between 2 points, 1 face, 3 points, 3 faces. And now we need to iterate through that. Sorry, I'm being lazy here. I'm just gonna copy and paste stuff. Of course, you don't need to declare an extra int, but I want to keep it readable. So now let me think. We basically, the first like this one and this one we can just add. So let's say add bottom and sides dot add top. So this is all arbitrary. Like that is the point where, or the reason why really scripts like that are hard to read if you didn't write them yourself, because here I just make a decision. I'm gonna start at the bottom left corner. I'm gonna move up to the top, and then I move to the right and then down again. So you could do it in any other way. You just need to know where, in what order your vertices are, so you can draw the tries or declare the tries in the right order as well. So now I'm just going to write a line and then I'm going to explain it. We now need to get an index for the other two. So let me just write it out first. Okay, so what this is, like the syntax to start with is an if-else statement. I just like it because it keeps things a bit shorter. So it basically means if sorry if that's a bit dragging if you already know how it works, but I think this one is a good one to know. So it's basically nothing else than an if-else statement. I do have an error, of course, here. And all it says is if this, the question mark indicates the if statement. So if this is true, then use the first statement, colon, if it's false, the second statement. So now to our content. Let's look up here. Let's choose this face. It's easier to read. So we start with the bottom left, which would be 2. We move up to 5. That is all working pretty well. And from here we know if we move to the right, we need to get one less than we've had before. That's where the -1 comes from. So we have the index -1. So if we are, in this case, this would be phase number 2, or with the index 2, we start with 0, phase 1 is in the back, and this is phase 2. So this one works, and then here we have 2 -1. So in our top array, this is the index 2 -1, index 1. So this would be 0, 1, 2. Sorry if that's all confusing. I hope you can follow me, sort of. And now this is all I want to do. And of course the same one on the bottom. We have this one. And all we need is to go subtract 1 to get to the other side. The problem is, if we look at this phase, we got 0 here and we got 3 here. And 3 -1 would be 2, and 2 is not part of this set of indices. And 0 -1 would be -1, which also doesn't exist. So what we need to do is we need to check if it's less than 0. We need to add the amount of phases. So this is basically this if statement. We just need that for this very phase. For the other ones, it would not be necessary. Okay, long story short, sorry that this is so dragging. Let me just copy and paste. And of course, we now need to flip it around. I said this is, again, my arbitrary choice to move around clockwise in the square. And instead of I, we use our index. Okay, that much for our vertices. Now let's look at the tries. Sorry, this session is turning a bit longer. I just wanted to finish that one. So, sides, tries, sides. So now for the tries, we don't need to pass in anything because the tries depend on the vertex array, which we already declared, and now we just need to find the right algorithm to make this work. So I'm gonna refactor this to sides. And again, amount of phases. You can just use points length in the for loop. So amount phases. Okay. So this is our basic setup. And now we just need to think that through. What would be a good way? I've decided I just want to start with the bottom, our bottom vertex, go this way clockwise, and basically I'm gonna use, sorry about the drawing, I can do that better. So, beautiful. So this is triangle number 1, and this will be triangle number 2. And we have to do this on each of the faces. That's why we're looping through the amount of faces. So if you remember the triangles, we went through it. They depend on the indices of the vertices. So our vertex array right now holds first all the vertices on the bottom, second all the vertices on the top. So this is what we need in order to access the right ones. And the triangle array holds right now all the triangles for our top face, all the triangles for for the bottom face, all the triangles for the top face, and now at the end we want to add all the triangles for our side faces. So need to keep that in mind. I think I just gonna write it out and then we can actually, let's see if I'm allowed to copy and paste. Sometimes it doesn't work. So yeah, just take your time and write everything down. And we don't have a J, we have an I here. So the first thing I'm doing is to create an offset, which is sorry, I forgot. For our vertex array, we have first the bottom vertices, then the top vertices, and then our side vertices. So if we want to access them, the side vertices, we need to have an offset holding the bottom vertices and the amount of the top vertices all together. So this is what we do here. We create our offset 2 times points length, and then we are iterating through each face. So after the first phase, we've added 4 vertices. So in the second phase, we need to have another offset of 4. This is where our I times 4 comes from. And getting the triangles, I'm just getting them both here at the same time. So the first triangle would be the bottom offset plus 2, offset plus 1. Okay, basically we're jumping from this vertex to this vertex to this. Need to do it counterclockwise so it's facing the right direction, and then we move to the other, this one to this this way around. I think I hope I remember that right. You can have a look at it in detail. Yeah, I don't want to track this session too much longer, but this is the way I was thinking when I created, or when I thought of the script. So now all that's left is to hit play, and we've got our object. It doesn't look all that pretty. It's more like this blurry black hole in space, which is kind of cool actually, but that's not what we want. It would be distracting, especially since in edit in the scene view it's changing so much as you just move around. And the reason for that is actually that we don't have added any normals. So let's have a quick look. Our mesh component has, let's just do that here at the bottom, normals. Our mesh does have an attribute called normals. It's a vector 3 array. So we actually could create this array. We could add all those normals by hand and could even adjust them if we want a special whatever, if we have special needs for physics or something for our 3D object, then it would be helpful to do so. But in our case, the easiest way to get the normals right is to call a function called Recalculate Normals. And this handy function does what it says. It just recalculates them. Since there have not been any, I assume it just creates all the normals, because this looks pretty good to me. So there we created our 3D, or yeah, our polygon, our 3D area. Of course, you still can play around with the way it's displayed. Can set it to transparent, give it some color. So if you place that in a scene like this, it wouldn't be as annoying as if it had a solid color and you cannot see what's behind. That would be a hindrance, of course. So this is it for this session. Thank you for watching and holding on. In the next session, what we're gonna do is similar to our waypoints tool. I just want to wrap it up as a tool for now. There's still lots of things I got in mind for our area tool, but I want to leave it at that and just switch over to other branches of my tutorial series. But yeah, what we're gonna do is we're gonna add the tool to our creation list. So there's a different approach we need to take here in order to make this work. And what I also want to cover is how to save this 3D object as a prefab. Yeah, I'm actually not sure if we do it as a prefab or as a 3D object. Yeah, we'll look into that, but I definitely want to get it out. You know, if I uncheck play, it's all gone. We cannot see it anymore. And maybe you just have a shape what you need more often. If you have some houses same size, you don't always want to start again with your waypoints tool. So maybe that comes in handy. So we'll do that next time. Thank you again for watching and see you then. Bye.